All right, let's talk about string theory. But hold on, we're not going to rehash the same old debates you've heard 1,000 times. Instead, we're going to pull on a thread that, honestly, reveals a much deeper, more fundamental question about what it even means for a theory like this to be complete. So yeah, let's just dive right in.
Okay, so when people criticize string theory, this is usually ground zero. You know the line, we can't test it, so is it even science? And look, that's a totally valid point. It's a huge part of the conversation. But for today, we're just using it as a starting block, because we're about to go way past it.
Exactly. What if the lack of testable predictions isn't the real problem at all? What if it's just a symptom of something else? Something more fundamental? A problem not with the answers the theory is giving us, but with the very components it has to ask the questions in the first place.
To really get our heads around this, let's try an analogy. Let's stop thinking about a physical theory as just a big pile of equations. Instead, let's picture it as a piece of conceptual machinery. For it to work, it has to have all its parts, and all those parts need to fit together and run smoothly, at least on paper.
So what does that actually mean, conceptual machinery? Well, think of it this way. A theory can't just have a user manual that says, a string vibrates and that makes a particle. No, it needs the actual blueprints for the string itself. It needs to show you all the gears, all the levers, the power source, and explain exactly how they all work together to produce what we see. Now here's the catch. According to the source for this explainer, a theory can be incomplete in a few different ways. Some parts might be fully fleshed out, working machinery, but other parts, they might only be described in the manual. It's an idea without a real blueprint. And then there are the crucial parts that aren't mentioned at all. The argument is that string theory has bits and pieces at all three of these levels.
So let's apply this machinery test to the most basic piece of the whole puzzle, the string. What is it really? Is it a working part of the machine, or is it just a cool idea written down in the manual?
And this is where we hit our first major snag. The theory treats the string as a textbook object. It's an idealized concept, right? A perfect, one-dimensional line that resonates, but nothing in reality is truly one-dimensional. It's an instruction in the manual, not a blueprint for a real component you could build.
This table just breaks it down perfectly. The idea in the manual is elegant and simple. A vibrating object, and its vibrations create particles. Simple enough, but the blueprints for the machine, they're full of holes. How does it keep its shape while vibrating? What are its actual properties? These nitty-gritty mechanical details are just undefined.
I mean, seriously, this is the most basic question you can ask about any physical thing. If the string is the fundamental building block of the entire universe, you've got to ask, what is the block itself made of? It's a foundational question, and the manual is completely silent.
And you see the same problem with interaction. We're told a string is supposed to interact to form everything we see, but the how, the actual gears and levers of that interaction, are just missing from the blueprint.
And this question really shows you how deep the problem goes. A string isn't just floating in a void, right? It has to exist inside of space-time. So how does it do that? What are the connections, the attachments, the rules of engagement between the string machine and the space-time machine? We just don't know.
Okay, let's move on. Let's look at another famous piece of the theory and see how this problem builds. Those extra dimensions. String theory needs them, way more than the three spatial dimensions we know and love. But are they working machinery?
It's a beautifully simple way to put it, isn't it? If these extra dimensions are real, they have to be made of something. They have to be a physical part of this universal machine. So what is that stuff, and how is it all configured? And yep, just like with the string, how does this dimensional machinery connect to everything else? How do these little curled-up dimensions actually influence the particles we can see? The specific gear and lever connections are once again missing from the blueprint.
So if these really fundamental parts of the theory seem more like ideas in a manual than working machine parts, what could possibly be going on? Well, this is where our source offers a really fascinating, almost philosophical twist.
Just take a second to let that one sink in. What if the extra dimensions aren't actual physical places at all? What if they are a mathematical tool that bridges the gap between objective reality, what's really out there, and the very limited way that we, as human beings, are able to see and measure it?
This just reframes the entire problem. Maybe the theory's incompleteness isn't a failure to describe reality. Maybe it's an accurate description of the limits of our own perspective. The missing blueprints might be missing for a good reason, because they describe something that is, by its very nature, beyond our conceptual toolkit.
And really, this all leaves us with a profound question that's so much bigger than just string theory. What do we actually demand from a final theory? Is it enough for it to just predict outcomes and give us the right numbers? Or do we need it to give us a complete, intuitive, mechanical blueprint for how the universe actually functions? Now that's something worth thinking about. Thanks for tuning in.